This is the first part of a review session for Unit 3 in Applied Statistics. For this first part, we're going to talk about hypothesis testing problems. We're going to start with the first set of problems where the idea is to write the null hypothesis and the alternative hypothesis, then describe a type 1 error, and last of all, determine the appropriate type of test or the appropriate StatCrunch procedure to use. And we've got a list of what those different types of tests and different StatCrunch procedures are. For all of these, when you're thinking about writing the hypotheses, remember to look at the claim. That's going to tell you what kind of parameter you have, what your inequality is going to be, and what number to use in your hypotheses. You can also think at the same time about what procedure you would use in StatCrunch. Sometimes pulling up that procedure in StatCrunch will help you determine what your hypotheses are going to look like. Let's start with number 1. In this one, we have a survey, and we want to test the claim that union support for the Republican candidate is over 70%. So when we're looking at the claim, we're talking about testing something to do with the percentage. That means that we're actually testing a proportion. If we think about what we would do in StatCrunch, that means we've got a proportion test, and since we only have the one sample, that would be a proportion one sample test. As I was saying earlier, if you pull up that procedure in StatCrunch, if we pull up proportion stats one sample with summary, that's going to give you an idea of what the hypothesis test should look like. We need to figure out what number to put in here and what inequality to put in here. The other thing about hypotheses is that we never use the significance level when we're talking about the hypotheses. You don't ever put the significance level into StatCrunch anywhere. For now, we know we're talking about a proportion, so our parameter is P. The claim is that that proportion is over 70%, so we're going to write our alternative hypothesis as P is greater than 0.70, and then our null hypothesis is the same thing with an equal sign replacing the inequality. So there are our two hypotheses. The type 1 error is always reaching a conclusion that you're going to reject the null hypothesis. In other words, that you're going to find sufficient evidence to support the claim when the claim really isn't true. In this case, it would be concluding that the union support really is over 70% when it actually is not. And again, in StatCrunch, what we would use would be the proportion stats one sample. Let's go on to number 2. In this one, if we look at the claim is that the average cholesterol content in a chicken egg is different than 213 milligrams. Right here we have the word average. That's a keyword to look for. In the claim, that means that we're doing a test about a mean. Our alternative hypothesis is going to be that the mean is different than 213. Different means using a not equal to. That means our null hypothesis is going to be that the mean is equal to 213. A type 1 error would be concluding that the cholesterol content is different than 213 milligrams, since that was our claim, when it actually is not, so when it's actually equal to 213 milligrams. In StatCrunch, anything to do with a mean or means, that means you're going to use t-stats. If we look at the t-stats, this would be a one sample with summary. Notice how it fits the information that we have. So it's asking for a sample mean, sample standard deviation, and a sample size, which we were given all those things in the problem. And here's what our hypothesis tests are supposed to look like. If we were doing this in StatCrunch, we would make that a 213, and we would leave this as a not equal to. Let's look at number 3. In this one, subjects were asked to measure their pain on a pain scale both before and after hypnosis. What that means is that for each subject, there are 2 different measurements, and that tells us that this would be paired samples. The only procedure that we do that has to do with paired samples is about the mean of the differences. If we look at that in StatCrunch, we would be doing t-stats paired. This was the only paired one that we ever used in this class. And from this, if you pull this up, you can see what the hypotheses are supposed to look like. They have the mu with the subset of D for difference. In all the ones in this class where we had two samples or where we had paired samples, we leave the number in the hypotheses as a 0. So the only thing we would have to change would be the inequality. And for this one, since they talked about the before first, I'm assuming that we're taking the before rating minus the after rating. That means if the pain measurements were lower after hypnosis, that means the after ratings were lower, which should mean that our difference was positive. If we're taking a bigger number minus a smaller number, we should get a positive number. That's how I came up with the greater than to put in the inequality. This one, you kind of have to think through that to get that inequality right. For this one, a type 1 error would be concluding that the pain measurements really were lower after hypnosis when they actually were not. And as we saw in StatCrunch, this would be a t-paired test. For number 4, in this one, the claim is that the standard deviation is less than 0.02 centimeters. For these problems, if it has to do with the standard deviation, it's going to use the word standard deviation in the problem, in the claim. That automatically tells us that our parameter is the sigma, which is the standard deviation. The claim is that the standard deviation is less than 0.02, so that's where we get the inequality and the number here. And then our null hypothesis is just replacing that inequality with an equals sign. A type 1 error would be concluding that the claim is true, so concluding that the standard deviation is less than 0.02 centimeters when it actually is not. For the standard deviation, we actually use a chi-square one-sample test. In StatCrunch, there isn't a test for standard deviation. In StatCrunch, we have to use the variance procedure for this. This is the one that's a little bit complicated because this is actually talking about the variance. The variance is the square of the standard deviation. When it asks for the sample variance, that means you have to take the sample standard deviation you were given and square it and put that value in. And even in the hypotheses, notice that this is sigma squared in StatCrunch, where our hypothesis was sigma. So this number, the 0.02 that we had in our hypotheses, you also have to square that to get the right number to put into StatCrunch. Let's look at number 5. In this one, we're talking about the brain volumes of afflicted and healthy patients. The claim is that the average brain volume for afflicted patients is different than the average brain volume for healthy patients. First of all, we're talking about averages. That means that we're doing some kind of test to do with means, which also says that we'll be using t-stats in StatCrunch. And this time it's talking about two different averages, the average for the afflicted patients and the average for the healthy patients. So we're talking about two different means. That means that we're doing a t-stat 2-sample test. And if we pull that up in StatCrunch, we can see what the hypotheses look like. We've got the mu1 minus mu2 is equal to 0 for our null hypothesis. And then for the alternative, we just have to decide what that inequality is. This time it just says that the average is different. Different means not equal to. There are our hypotheses. Then for the type 1 error, that would be that concluding that the claim is true, so concluding that the average brain volumes are different when they actually are not. In number 6, the claim is that there's more support now for abolishing the penny than there was in 2004, and in 2004, only 23% of American adults supported it. That's saying that the percentage now that support it is more than 23%. Our alternative hypothesis would be P, because we're talking about a percentage or a proportion. It's greater than 0.23. So our null hypothesis would be that P is equal to 0.23. A type 1 error would be concluding that that claim is true when it actually is not. And this, since we're talking about a P here, this would be a proportion one-sample test. Notice that they only gave us data from one sample, so we can't do two samples, we can only do one. In number 7, this one we're talking about candidates who won elections and then the people that came in second place to those candidates. We're testing the claim that on the average, the winning candidates are taller than their second place counterparts. In other words, for each winning candidate, we're also looking at the person that came in second place in that race. So this is a paired sample situation. That means that our parameter is the mu sub d, it's the mean of the differences. And if the winning candidates are taller, that means that if we subtracted their heights, we'd get a positive number. So we want the mean of the differences to be greater than 0 for our alternative hypothesis. A type 1 error would be concluding that the claim is true, so that the winning candidates are taller than their second place counterparts when they actually are not. And this would be a t-paired test since we're talking about the average. That means it's t-stats, and since we're talking about paired samples, it would be t-paired in StatCrunch. For number 8, this time we have 2 different samples. We've got 40 claims from the 20 to 24-year-old drivers, and we've got another 40 claims from the 30 to 59-year-old drivers. We want to test the claim that the average amount for the 20 to 24-year-olds is higher than for the 30 to 50-year-olds. So this time we're talking about 2 different averages. We've got the average for the younger people and the average for the older people. So we have 2 different means. Our hypotheses look like this with the mu sub 1 and the mu sub 2, the 2 different means. And since we're talking about the 20 to 24-year-olds first, we're saying their claims are higher, then this would be a greater than for our inequality. A type 1 error would be concluding that the average for the 20 to 24-year-olds is higher than it is for the 30 to 50-year-olds when it actually isn't. This time, since we've got the 2 different means and we're talking about the averages for the 2 different groups, they're not paired in any way. That means it's a T2 sample test. In StatCrunch, we would use the t-stats 2 sample. In number 9, in this one also we have 2 groups of infants, one that used bed nets and another group that didn't use bed nets. They're not paired in any way, so we have 2 independent samples. But this time when we're talking about the incidence of malaria, that means the proportion of the infants that actually came down with malaria. So this is a 2 sample proportion test. Our hypotheses have the P1 and the P2 for the 2 different proportions. And the claim is that the incidence of malaria is lower for the infants using the bed nets. Since the ones using the bed nets are mentioned first in the problem, that means that we want to make this a less than. So we want to make it fit what it said here, that it's lower for those infants. A type 1 error would be concluding that the incidence of malaria is lower for the infants using bed nets when it actually isn't. And this, in StatCrunch, this would be a place where you would use proportion stats 2 sample. In number 10, the first thing we can see is that the claim is talking about means. So the mean amount grossed by PG or PG-13 movies is higher than it is for movies with R ratings. We're talking about 2 different means, one for the PG or PG-13 movies, another mean for the R-rated movies. Our hypotheses are going to have the 2 different means in them, mu sub 1 and mu sub 2. And since the claim is that it's higher for the PG or PG-13, that means we're going to make this a greater than. A type 1 error would be concluding that the claim is true when it really isn't. And since we've got 2 different samples, we're talking about 2 different means here. That means in StatCrunch we would use t-stats 2 sample. One more of these. In this one we actually have the data. We've got prices for specific items at one particular store and at their competitor's store. The claim is that the store's prices are lower on the average than their competitors for specific items. Notice for each one of these items we have 2 different measurements, 2 different prices. That means that these are paired samples. For our hypotheses, we have the mean of the differences, so the mu sub d. Since the claim is that the store's prices are lower, then we want to make this a less than. A type 1 error would be concluding that the store's prices are lower on the average when they actually are not. Since we had paired data, then this would be t-stats paired in StatCrunch. For the next part of this, we're going to go back and do some of the hypothesis tests that were in the first 11 problems. First, we're going to go back to problem number 1. So we're going to take the data from this problem and actually run the hypothesis test in StatCrunch. For this one, we decided that this was a proportion one sample test. So I'm using proportion stats one sample with summary. Since we don't have a list of data, we just have the summary data. In this case, we had 297 that favored the Republican candidate out of a total of 400. Our number of successes is the 297, and then our number of observations, that's the sample size, would be 400. We're doing a hypothesis test, and we want to use the 0.70 for p, and our alternative hypothesis had a greater than. Remember, when you're doing this in StatCrunch, you don't ever put in the significance level into StatCrunch. So now I'm clicking on compute, and here are my results. My test statistic is right here, so it's 1.85. My p-value is 0.0318. In this one, it asked us to test at a 0.05 significance level, so we're comparing the p-value to that significance level. The p-value is less than 0.05. That means we have a positive conclusion. So there is sufficient evidence to support the claim, which was that union support for the Republican candidate is over 70%. For number 13, we're running the test in problem number 2. This was a T1 sample test, so we're going to use the t-stats in StatCrunch. So here's my t-stats. This was just a one sample with summary. You want to make sure that what it's asking you for in StatCrunch fits the information that you have. In this one, they have the sample of 45 chicken eggs, so there's our sample size. It gave us the sample mean was 209 and the sample standard deviation. And those are exactly the three things that StatCrunch is asking for. So we have 209 for our sample mean, 15.9 for our sample standard deviation, and the sample size was 45. Then here's our hypotheses. So we're putting 213 in for the number. We're leaving the inequality as a not equal to. And here are our results. So our test statistic is negative 1.69. Our p-value is 0.0986. We were supposed to test this at a 0.05 significance level. This time the p-value is bigger than the significance level, which means we get negative conclusions. There is not sufficient evidence to support the claim, and that was that the average cholesterol content in a chicken egg is different than 213. In the next one, we're going to go back to problem number 4. This was the test that had to do with the standard deviation, so we're going to use the variance stats in StatCrunch. It's asking us for the sample variance. If we look at our sample information, we had a sample size of 52, tells us the mean, and the standard deviation from the sample was 0.016. To find the sample variance, we need to take 0.016 and square it. If we do that, we get 0.000256. You have to enter all those digits into StatCrunch. Our sample size was 52. And then for our hypothesis, we also have to square the number that we used in our hypothesis here, since this is the standard deviation. When we do this in StatCrunch, this is that squared, so we have to square it. So 0.02 squared gives us 0.0004. Then our inequality is a less than. These are the results that we get. Our test statistic is where it says chi-score stat, so that's 32.64. Our p-value is 0.0212. For this one, we had a 0.05 significance level, so we're comparing the p-value which is 0.0212, it's smaller than 0.05. That means we have positive conclusions, so there is sufficient evidence to support the claim. For number 15, we're going back to the information in problem number 8. This is the one where we had the test about the two means. So this was a T2 sample test. In StatCrunch, we're going to do T-stats 2 sample with summary. So it's asking us for two sets of information, the sample mean, standard deviation, and sample size for each of our two samples. And we want to put this in the same order that we had it in the problem. The first set was for the 20 to 24-year-old drivers. So we're putting in the mean and the standard deviation, and the sample size is 40. And then for the second set, for the 30 to 59-year-old drivers, we have a mean, a standard deviation, and a sample size. And then the only thing we need to change in our hypotheses is the inequality. We get these results. Test statistic is 1.82. Our p-value is 0.0366. This time there was a 0.01 significance level. If we look at our p-value is actually bigger than our significance level, which means we get a negative conclusion. So there's not sufficient evidence to support the claim that the average claim amounts for the younger drivers was higher than that for the older drivers. In the next one, we're looking at problem 9. This was the one about the bed nets for the infants. So this was a proportion 2 sample test. So we have proportions 2 sample with summary. For this one, we need to put in the number of successes and the sample size for each of our 2 samples. Again, I'm doing this in the order that it comes in the problem. So the first set of infants we have is the ones that did use the bed nets. So we had 21 successes out of 301. For the second set, it was 26 out of 272. And then our inequality had a less than. So I'm changing that to a less than. And we've got our results. So our test statistic is a negative 1.12. Our p-value is 0.1303. If we have a 0.05 significance level, our p-value is greater than our significance level. That means we have a negative conclusion. There is not sufficient evidence to support the claim. And last of all, for problem 11, we're going to go back and run this test. In this one, we had the data, so we actually need to copy and paste this into StatCrunch. When you're taking your exam, hopefully it will work for you to just open the data set in StatCrunch. If not, you can always copy and paste it like I'm going to do right now. So I'm just copying this. The only thing you really have to be careful of if you're copying and pasting into StatCrunch is that if you've got the column headers, you have to start with the column header row like this. Here's my data after I copied and pasted it into StatCrunch. What we're doing for this is a t-paired test. So I'm doing t-stats paired. The data that came first in the problem was the store. Second was the competitor, so that's the way I'm putting it in here. And then our inequality was a less than. There are my results. My test statistic is negative 1.06. My p-value is 0.1578. So at a 5% significance level, that's the same as 0.05, my p-value is much bigger than my significance level. That means I have negative results. There's not sufficient evidence to support the claim that the store's prices are lower on the average than their competitors.